So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 360 and in this video we continue again with our user-defined conversion function examples. We stopped last time here and now we continue. Okay, let's go to the next comment section. This is this part here and it says here, if conversion function is from a non-const type, for example, from operator 2. So let's go to the from section. We have here the operator, and this example here is a non-const type, and you can see in our example here on top, we have a const in it. So this is the only difference is here is a const and here is not a const. Then it will be selected instead of the CTOR in this case. Why is that so? The reason is again internal rankings of the compiler, because the compiler has now here two options. One, this version without const, or the constructor here on top, which has the word const in it. Then the compiler says internally again, okay, the version with const is more work because there is a const qualification, and the version without the const in this operator is less work without const qualification work. Then the compiler is again selecting the less work and it's selecting just this one here. Okay, let's go to the next example. And again, we create a new object called T3 again with the type 2, which is this one here on top. And this time we are using static cast. We already learned static cast a little bit and know that a static cast is a conversion. But the nice thing about the word static cast is we see it as a programmer, that here a conversion will happen, and the conversion is happening exactly here, and then this part is then initialized to T3. And again, static cast, the whole thing here will perform a direct initialization. That's very important to know, because again, we learned that direct initialization will all time prefer the constructor, that one. And if there is no constructor, again, then it will not choose this operator here. Instead, it will create again the copy constructor here, and then the copy constructor will call the operator here. Okay, let's go to the next line and analyze it. It says here, it is a reference initialization ambiguous. Again, this is not true, because the new standard can resolve that. Okay, let's start with the syntax here. First, we have here the word const, and the const has many meanings, and we will figure out what the meaning here is in a moment. Then we have here our to, this is our to struct here on top. Again, we have here the converting constructor available. Okay, then we make a reference. And reference means we are binding to an existing object. Yes, our object f is here created, and the reference name is r. This is not ambiguous because the compiler has an internal ranking, and this internal ranking will find probably that the struct here with the converting constructor is preferred in this. But let's see what we try here to do. We try to bind r, which is of type 2, so it's from our struct, to f, to the object f, which is of type from. And here we need a conversion, because this binding is normally not allowed, but it is only allowed with a conversion. And we have here the two options again. That's why it says here ambiguous, but we know it is not ambiguous now, because the compiler will choose in this case the converting constructor, and we can go on from here. So what happens here now in the converting constructor is it says, okay, I take f here as an argument, and then I convert f to the type 2. And very important now, it is creating a new temporary object here in the converting constructor. Then the r reference here is binding to the new created temporary object from the constructor. So, and we learned a temporary is a PR value, which means if you bind it not, it will go away. And that's why we need this word const, because we learn if you use const, you can bind to temporary values, PR values, R values, and so on. And then it extends the lifetime. That means it is still available even it is just a temporary value, which will be normally destroyed after the semicolon here. But in this case with const, it will be not destroyed, and you can use it. A very important side note is, what does it mean we bind here to a temporarily created object? Normally, when you reference an object, not like this one here, let's say we create just a normal reference to an existing object, we would access this object directly. It is just an alias, but in this case, it is not an alias because we are not accessing directly the object memory. Instead, we are creating a temporary object and we binding to this temporary object. And that means if the original object changes later, let's say after this line here, the original object is changing, our binding here, not the changes, because we have just bound to the copy of this object here. Okay, that's enough for this video so far, and like all time, if you have any questions, write in the comment section. See you in the next video. Bye and good luck.